Hello there, welcome back. Right, we've seen a lot of great stuff already today, really interesting things, and we've got more great stuff coming up in the next few sessions. This first one is a pretty short session on sensors and proximity, so NFC and Bluetooth. Now it's only a short session, which is kind of tragic because there's so much interesting stuff in there. But
it's a theme today.
Exactly, yes. So this is a jump start. The idea is we give you a taste of what it's like to work with this stuff. So in this session, we're going to just look briefly, and I mean briefly, at using sensors, how you program them. But really, what we're going to talk about, for the most part, is Bluetooth LE and NFC. Not actually in the order that they're shown on here. So, Bluetooth LE and NFC enhancements, so of which there are many in Windows Phone 8.1. So first of all, just very briefly, really, looking at the different sensors and how you work with them. This is using the Windows Runtime APIs. First of all, we have lots of sensors. Now, not every device will have all of those sensors, and this is a converged API. So as you can see, we've got actually the graphic there. We've got a tablet shown, but these are available obviously on the phone as well. Compass accelerometer, gyrometer, the orientation light sensor, and an inclinometer. So if you want to get real world settings about the way your device is tilted, oriented, or being turned or dropped, you can find that out. There's lots of raw sensor types. You can get hard, raw readings from the accelerometer, magnetometer, gyroscope. But then there's also these what we call derived sensors. And actually, in fact, there's not much point in saying too much about them because from a programming point of view, they're just objects that you interact with. But what those are is that the derived sensors, they actually take an amalgamation of raw readings from some of the more direct sensors, and they do some clever mathematics, and what they give you is a kind of a smoothed or an optimized signal, which gives you some of these other sensor readings that are listed down here. But you use them all in much the same way. The way you first of all, you have to make sure that a particular sensor is available on the device. So first thing you almost do is you call the get default method of any of these particular sensors. They all have this, and if that device is present on the device, if the sensor is available and present on that device, you will get an object back. And if it's not been installed by the manufacturer, then obviously that will return null. So that's essentially the first thing you must always do with any of these sensors. Then when they actually get turned on and turned off kind of automatically when you start using them. So when you hook up a reading changed event or you actually do a direct reading of the device, that will power it up and activate it, and you'll get the information you want out of it. And once you've set you need to set the report interval to a non-zero value prior to registering an event handler. Or calling get current reading, and that is the trigger that will actually activate the particular hardware. So if you want to use a reading changed event, then you set your report interval and hook up your reading changed event handler, and then you will get events being fired at the report interval. The report interval just is a throttling device, so you don't get overwhelmed with readings. So you're saying, okay, I only want to get an update every 100 milliseconds, is the example here. You'll get then the event will fire, and you can read whatever data it is that particular sensor gives you. Obviously, this is a gyrometer, which gives you back a gyrometer reading changed event args, and from that you can get an angular velocity of x, y, and z. And obviously the different sensors have their own flavor of the reading changed event args, which gives you the particular sensor readings data that sensor returns. You can obviously poll it as well, so that's the other way, is not using the event handler. You can simply, and at intervals, call the get current reading method of it, which gives you an instantaneous reading back from that sensor. Gives you, obviously returns the same data, but it gives you more control over when you actually get a reading from it. And notice that bottom point on the slide. You still need to, even if you're only doing one reading, you've got to set a desired report interval before polling, because that's the trigger that actually activates the sensor. So in order to get some sense out of it, you need to do that. Like I said, short and sweet. I'm not going to do a demo on that because I really want to get into almost the more interesting stuff, if you like, which is Bluetooth and NFC. Bluetooth first. So we've got 4 Bluetooth scenarios, four kind of ways that you can use Bluetooth in a Windows Phone device or a Windows device. So first of all, we've got this app to device thing. So here we've got an external device, some kind of Bluetooth device that has been paired with your phone. And the program can enumerate the paired devices and can establish a connection to it, so it can interrogate for the services that that device offers, can connect to that service, and then communicate directly with that device. There's app to app as well, and an application can communicate with another instance of itself running on a different device. So there you've got the same app has been installed on 2 actual devices, and one device can actually start searching for itself running on a nearby device. So it obviously uses the Bluetooth radios, but built into the phones is the ability to discover if the app is present on the other device, and when that app is running, they can communicate with each other over the Bluetooth connection, and pairing is not required for that. Then we've got 2 new ones in Windows Phone 8.1. First of all, we've got Bluetooth RF-COMM, which is often called serial port emulation. So RF-COMM is a particular sort of set of standards for talking over RF-COMM as if it's connected by an old-fashioned serial cable, except of course this is that cable replacement, which was kind of the early promise of Bluetooth, was what it was going to get rid of all these cables that you used to use to plug everything in. So RF-COMM is supported. And Bluetooth GATT to access Bluetooth LE devices. This is actually the most exciting one of all of these. So go through one of those in a little bit more detail. App to device. Like I said, you can get an enumeration of all the Bluetooth devices that have been paired, and then it can attempt to make a connection to that service. You have to understand what the protocol is that device understands, and you just get a stream socket object, and basically you just have to write the correct bytes for whatever protocol that device understands onto the wire, and understand the protocol, the handshaking protocol for message exchange for that device. So this is kind of a very roll your own kind of solution. App to app is interesting because you use this peer finder class, which you have the apps running on 2 devices, and then one app can actually start searching for an instance of itself running on a nearby device. And when it discovers it, then events fire and they can set up a connection between them. So this one, the devices do not need to be paired. You still need the proximity capability. These have been in since Windows Phone 8. So I'm not going to talk any more about them. If you want to find out more about those scenarios, there is a simply awesome video from the last Jumpstart series with myself and Rob Tiffany talking about the NFC and Bluetooth support that was in Windows Phone 8. And everything we've got obviously in this release builds on top of that. So in the interest of time, I'm not going to go through those 2 all over again. So what's new then? RF-COMM, LE, which is also called Bluetooth Smart. And actually the most exciting thing is some triggers. This is really the magic that allows interesting stuff to happen, because it means your foreground app doesn't need to be running in order for your app to be able to interact with a Bluetooth LE device. RF-COMM, this is kind of almost for, you could call them almost more legacy Bluetooth services, ones that understand RF-COMM protocols, which is this serial port profile. So you've got this client and server service discovery, SDP thing. So you can discover services that are available on a Bluetooth device that understands these things, can connect to it, and as the graphic there suggests, you can kind of connect the unconnected. You could have a Bluetooth system in car, for example, and use your phone, an app running on your phone, as a kind of gateway to the cloud and to expose interesting new scenarios in communicating with that embedded hardware. And I'm not going to talk any more about that because this is the one I really want to go and talk about. Bluetooth LE. So Bluetooth LE, Bluetooth Smart, is otherwise known as Bluetooth V4. And this is fairly new, but it's really amazingly popular. It's becoming super popular. There's loads and loads of devices coming out. And it's all part of this Internet of Things phenomenon. What's interesting about Bluetooth Smart, Bluetooth LE, is that it's really optimized for very low power devices. So you can have I've got a little device here, which is it's actually a little key fob, which I'm going to do a demo with in a moment, and it just has a little cell battery in it, a little watch battery in it, which it can run on for 6 months or more. And the other good thing is, from the phone's point of view, is that it's very easy to make a Bluetooth LE connection and then drop it again. So it's very power efficient. So the kind of scenarios it's really good at is exactly this kind of Find My Keys thing, where your phone is you've got your keys in your pocket, and the phone is got a connection to it, which it can maintain a very low power output. And then as soon as you put your keys down and walk off without them, your app will fire up, and you will know that the connection has been dropped. And this making connections, dropping connections very quickly and efficiently is what it's all about. So we've got great support for GATT, which stands for Generic Attribute Profile, which is we've got this Windows Runtime API for GATT, which allows you to interact with Bluetooth LE devices. We need to put some stuff in the manifest when you're talking to Bluetooth LE, to GATT, and actually also with Bluetooth RF-COMM has a similar kind of thing. You need to put this into the manifest. Now, I'm particularly calling this out because unlike most of the other stuff we've seen in this Jumpstart, there isn't any designer support for this. So you can't go into the manifest designer and check some checkboxes and fill in some values and drop down boxes and things. You have to come in and manually edit this. So you need to right click in Solution Explorer, use Open With, and choose the XML text editor. And you go in and you add this in. I'll show you in a sample exactly where this goes. Now, some of the data on here, the model, and that's the identification of the actual particular device. So you need to find out what that is, or any device. And then you're looking for the name is the manufacturer's name, and then the heart rate. This is a fixed service name, which is, these are all controlled names by the Bluetooth Special Interest Group, the Bluetooth SIG, who are writing the standards for all of this sort of thing. So it means that all Keyfinder Bluetooth fobs will all have the same service on it, or a heart rate monitor will all have a service called heart rate on it. So you can write generic code that's going to work with devices from different manufacturers. And if you don't want to use the name : heart rate syntax, you can use this service ID : and then you put a GUID identification in that. So there's a little bit of stuff there you need to do. Now, a little bit of code I'm just going to show. The Bluetooth LE Health. This is an example of connecting to a health thermometer, a Bluetooth LE thermometer service on a smart thermometer. And the first thing is you will always do windows.devices.enumeration.device.information.find all async. Now, one thing is, all these devices have to have been paired with the device first. So there's no kind of discovery without being paired. So this find all async will give you back, it could give you back a list of all the Bluetooth LE devices that have been paired with your phone. You can filter that by actually saying, I only want to know about certain devices of a certain class. So this is what this GATT device service.get device selector from UUID, GATT service UUIDs.health thermometer is a drop down. It will be given to you. This gives you the special UUID, the ID of a health thermometer service. So that will filter the list and just give you back any health thermometer services that you are paired with. And then you go down, reading down the slide, you connect, you get the GATT device service associated with that thermometer service, and then you can connect to it, and you can get the characteristics to read the data off the device. And you can hook the value changed event, and you can get readings back from that smart thermometer. You'll then, right, the bottom line is await thermometer characteristic.write client characteristic. So what you're doing here is talking to that smart device. You're telling it, please tell me whenever notify me whenever the temperature changes. So it's a two-way thing going on here. The service allows you at a primitive level to program certain aspects of that smart device's capabilities. So this is the one where you're saying, hey, tell me when the temperature has changed. And you then obviously have a temperature measurement changed event handler where you get some data and you would read it, and the bottom method there simply converts the byte data that you get from the Bluetooth LE device into something that we can actually read. So it comes out with the real number. So there's some bit shifting you have to do to figure out the data, and that again is all this will be in the specs for the particular Bluetooth service. Now, all of this is nice. That's the programming thing from the foreground app, but where it really gets interesting is in a sort of find my keys kind of scenario is what happens when, to connect to a device, to detect when a device is disconnected or has reconnected, and even when your foreground app isn't running. And that's what Bluetooth triggers is all about. We've got 4 of them. Device use trigger. So this is where the top 2 are for long running things. So the basic idea with a device use trigger is your foreground app actually launches this background task immediately, and that is maintaining the connection with the device. This is for kind of servicing the device, if you like, use it for doing firmware updates and this kind of stuff. The background task will continue even after the foreground app has been suspended. It will continue running in the background, finish its work, and it can have up to like 10 minutes to service that device. That's a device use trigger. So not quite like some of the other triggers that just start something off in the background. This is a foreground initiated background task. RF-COM connection trigger is kind of similar. Again, this is for an RF-COM device, and the foreground app establishes the connection, and then even after the foreground app has suspended, the background task, which has been on an RF-COM connection trigger, will carry on maintaining that connection with that RF-COM device. The other 2 are more traditional triggers, if you like. A device connection change. This is the one you'll use more often than not, is when a Bluetooth device becomes connected or disconnected. And this will fire up a background task, and this is the one which will raise an alert when you've left your keys behind or something like that. And likewise, a GAT characteristic notification trigger. This is something where you've got a Bluetooth LE connection, you're paired with a Bluetooth LE device, and you've sent a write characteristic to it to say, hey, tell me when such and such a characteristic has changed, whatever that particular service is all about. That health thermometer was a good example. And that says, okay, whenever that characteristic change, send me a message, and that will fire up the background task running on your phone to handle that message, and then your app can take action, put an alert up or whatever, update a tile or whatever it needs to do. Okay, so that's that. This is how you do an RF-COM connection trigger. You new up the device, and then thereafter you need to have this Bluetooth service UIDs. These are all fixed by the Bluetooth SIG. You then you program up your RF-COM connection trigger, and as with all the other background tasks, you have a background task builder, set the trigger to it, and now I'm going to show you a cool demo. So I've got here. I have got here a locked PC. Oh. Get that bit right. There we go. Okay, now I've got an app which is called Keep the Keys. And it's got a foreground app, Keep the Keys. We've got a background task, which has got a key fob task in it. I've got some breakpoints in here, so actually I'll talk it through as we run it. And then I've just got some common stuff which is used by both the background task and the foreground task. Most important here is this key fob class, which stores the state of the key fob object. I've also got here a device that's gone off. Why has my device gone off?
Top. The power button's on the top.
Oh, okay. And then it says allow screen projection. Okay, there we go. That's right, I was trying to take a picture. So,
oh, okay.
Yeah. And as you can see, it is Bluetooth is on, and I'm paired with this VTag, which actually is that little this little key tag I showed you just before. And we can first of all, I'm going to start running the app. Actually, I wonder if we can do some clever stuff here. Let's run the app, and it's going to start up on my device. And here we are, Keep the Keys, and the first thing that will happen is we will hit a breakpoint, which this is where we're going to enumerate and find all the paired devices. So we go and get we do device information, find all async. I want to get all Bluetooth LE devices, so we're finding out who we're paired with. And then we're just going to go and find that. And we're looking, we get our ID async, and we know we're going to new up our state object, a key fob object from this. Then the code just below that is all about managing our background tasks. Because you need code in here as well to remove registration background tasks for devices that you're not paired with anymore. So you need a bit of housekeeping code in there. So I'm just going to let that run, and you can see that on the screen I've got now that device is listed in it. I'm going to tap on VTag on this screen, and it's going to switch to another screen on here. This is where we can do the configuration for our device. So first of all, I'm going to tap, and whenever you change anything on this screen, because this is data bound to that key fob object, it's going to run some code in the key fob object which will register background tasks. At the moment I've got nothing registered. I'm going to create a phone notification on link loss. And then the other one is set device alert level on link loss. So what we're doing, the two things here, the top checkbox is for setting an alert on the phone, and the bottom one is for setting an alert on the device, because both are programmable. So I'm going to first of all set the one on the phone. We hit the breakpoint in our key fob class, and this is going to go down and say, okay, and this is have we asked for a alert on the device? No, we haven't, because what we've just done is ask for an alert on the phone. So then we go, if we got an alert on the phone, we new up a device connection change trigger, and we set maintain connection equals true, have our background task builder, and at this point I'm going to let it run, and we've now got a background task which will raise an alert when the phone on the phone when the link is lost. And before I do that, I'm now going to go over to my Bluetooth settings. I'm going to come back to this in a moment. Go to settings, to Bluetooth, and make sure we're connecting to that device. And we're pausing, and we're connected. There we go. And the device is just flashing a little light at me to say it is. And now I'm going to disconnect it again, so we should get the background task. Oh look, we just actually hit a breakpoint. We are now connected. So every time we connect, we also hit in this key fob. We're in the background task, in the background task we say if the device alert on phone, then we would have raised alert, but we're not disconnected. The logic was if we're disconnected. So run that, and now I'm going to disconnect it again by tapping on VTag in the Bluetooth setting. And actually my device is already programmed, so and then we're stuck in the keep the keys again in the background task. I'm going to let it run, and now I've got the alert has been raised. My background task has run on the phone and has told us that tag has been disconnected. Back to my app, and I'm going to let that run. This is now going to program the device. Device VTag is out of range. Hang on. Let's kill that breakpoint. It's annoying. Go. Just do what I say. Yeah. I know. Set a high alert on the device, and what I was going to do is get Matthias to walk out of here with the device, but let's not do that. You could take the battery out for me if you like. That would be the same as the key fob going away.
Okay.
So Matthias is just struggling with a coin over there. Disable all my breakpoints, so we'll just let it run, and actually let's just kill the app. And
is there a special way to pull this battery out?
Oh, you need to have a pen or something to dig it out, or
let me see.
So we're connected at the moment. And
Okay, I think I got something.
He's found a sharp object to prise the pen. There we go. The battery's gone. So in a minute, the device will effectively go away, and here we are. It's gone, and we should have all sorts of alarms will go off. Now our phone has said, yeah, the keys have been taken away. So no, it's. I hope that shows the power of what we've got there with Bluetooth LE and background tasks to build this kind of solution. Right, I'm just going to talk a little bit again about near-field communications, NFC. So this is for very, very close connections. You can tap the device to a NFC chip or to another phone, and you can exchange information. And it's assumed that this data transfer is intentional, so there's not normally any authentication because it's physical tapping them together. So you can go to unpowered things. There's lots of scenarios that we support. You can send short messages between devices. You can use NFC to bootstrap higher capacity connections. So you tap initially, and then it sets up a Wi-Fi or a Bluetooth connection for doing faster comms. You can emulate smart cards. So you can use it for transit passes and for doing getting through smart gates with like a smart card. You can read and write to NFC tags or smart cards. You can tap to share. That's all built into one of the sharing things to share pictures, contact cards, URLs, and videos. And also, it's available for secure NFC payment. That's a bit of a specialist field, so we're certainly not going to talk much about that some more. And we've been able to do short message exchange and that tapping to initiate higher bandwidth connections since Windows Phone 8. And yet again, in the same proximity and Bluetooth session from the last Jumpstart, you can find out a bit more about those. But what's interesting is new in 8.1 for Windows Phone NFC. First of all, whenever you tap to read, you always have this user confirmation thing, which kind of got a bit tiresome after a while. So we've now got this new trusted applications concept, which is really good. So that the first time you tap something to another device, it will say you still have to confirm it. But on subsequent occasions, a checkbox will come up to say, oh yeah, actually I trust this device, and thereafter you won't be prompted anymore. We've also got a whole overhaul of the UICC, which is actually the SIM card. The SIM card-based card emulation, so the secure element inside a SIM card, which enables all of these smart card scenarios. A whole overhaul of the APIs for programming that. We got lots of new card tag features and a whole new NFC driver model, which does have a side effect that some of these features are only going to be available on hardware that's going to be new phones that are going to be available later in the year. This is just a kind of recap of how you might use NFC to launch an app. This is an example of a short message exchange. You call proximity device.getDefault to find out if you've got an NFC chip in your phone. If it's not null, then you can sort of format a special format string and then call at the bottom publish binary message. And there are other publish APIs as well, publish string message and that sort of thing. So particular formats like launch app :write tag is a way you can get an app to launch on another device, such as a tablet or another phone. So you can tap it and launch it on the app on another phone. This is that user experience, the apps I trust thing. So, whenever you tap a device together to initiate something over NFC, the first time, like I said, you'll have to get that confirmation thing. But thereafter, you get this I trust this app, don't show this message again checkbox. And if you check that, then it's a trusted app, and you can see all the apps you trust in the NFC settings in the control panel, and obviously you can remove them from there as well. That's a nice user experience improvement, and everybody will get that. But now there's some of these things that are only going to be on the newer hardware because they need a new NFC chipset and a new driver. First of all, there is when you write tags onto you're writing onto a smart tag. They used to have to be a certain form. You can now format them automatically. So that's a real nice NDEF formatting. Automatic is a real enhancement. There's particular tags that are supported for there that are listed. You can also write and then set it as read-only. So that was something we couldn't do before. So it's a write once and scenario. So then it will lock the tag. And again, there's certain tags that will support that feature. But then we've also got this low-level API for a raw access to smart cards, which opens up all sorts of interesting scenarios, such as reading a transit card, the balance on it, and or adding funds to a debit card, and managing loyalty cards. So this read-write thing with all of these smart cards that are starting to become very popular for use by various consumers. And I've got a quick demo of doing that. I've got a new device connected now, which is a oh, hit the wrong button, sorry, which I'm just trying to get up on the this is a prototype, engineering prototype, and I would suggest they put the buttons in the wrong place. There we go. So this has got the new NFC hardware in it, and it's an engineering prototype which the team have lent me. Thank you very much for that. Let's go and open the particular project. Now this is a we're going to read. I've got here a German debit card. It's obviously a sample card. It's just a regular bank card, but it's got a smart card. It's an NFC enabled card. So I'm going to actually run an app here that is on this device, which the first thing it will do is it goes and finds out if we got any smart card readers on it. So it looks for, we've got a smart card reader get device selector to find out if we've got the smart card reader kind of NFC on it, and if we have, then we're in good shape. And the app will light into life. There we go. So we've got the right kind of hardware on it, and we've got no readings off it in the moment. So then I'm going to get this card and just hold it by the back of the phone, and you might be able to hear that. Now we've got this card added event handler. So I'm going to step into this where we can communicate with that card. So we actually connect async to our smart card. We then new up a data reader. And then we're going to go off, and for each in this Giroga read info sequence, what is that? Let's just have a peek at the definition of that. This is a list of NFC command sequences, which if we scroll down a little bit, it's just a list of bytes. These are the commands that this particular card understands. So we're going to send each of these commands in turn, and it's going to return the card details, amount details, transaction details, so information from this card. So what we'll do is, for each of those, we will send that, we'll write the bytes of the data reader of that command, and then we'll transmit that to the device, and then we'll get the response from the card. And all that get response from card is doing is using yet a data reader to read the byte response from that card. So I'm going to let that run. And over on the side there, you can see we've got the information from the debit card. Card ID, we've read off it, and the expiration date, and loaded amount, and all sorts of information we've read off this debit card. And if I now remove the card again, the card removed event handler will fire, which actually just clears the display. So nice and easy. And remove it again. Very simple, and it's quick and easy, and a nice way of interacting with smart cards. We've got also loads of great card emulation features, so we can actually, in the future, your phone will be able to act as a mobile wallet for payments, and there's a lot of standards and a lot of bodies who are involved in this, so it's kind of difficult to create these solutions because of all of the banks and the payment companies and the mobile operators and everything. At least from our side of things, we've made it much easier to create the solution. So it's now you don't need any, you used to need fancy drivers and special SDKs. Now all you need is the standard SDK so it's easy app development. There's still lots of other companies that have to get involved in getting a solution out there. All right, so that's a whirlwind run through a bit of Bluetooth LE and a bit of NFC, but I hope you're as excited as I am about what's coming up with this, particularly Bluetooth LE. Cool stuff you can do with that. We're going to take a short 5-minute break, or even a long 5-minute break, and then we'll be right back with contacts and calendars. Oh, and email with attachments, yeah.
Woo!
Right, hi there. Sorry for the bit of a delay there. I kind of got tangled up in USB leads and phones, and I had a bit of software that wasn't cooperating. So we're all fixed now and ready to go on with the next one, which is all about. Actually, the only thing anybody really cares about is how do I send an email with attachments. So that is in this module, but also it's kind of mixed up with the topics of contacts and appointments. So it's all about interacting. This kind of is loosely about interacting with finding out the contacts on the phone and then interacting with them. So we're going to look at the contacts access using the windows.applicationmodel.contacts namespace. And we're going to look at messaging. Now, messaging is like sending SMS and sending emails. And we're going to have and also have a quick look at calendar access through the Windows.applicationmodel.appointments API. So, the first thing to say about both of these sets of data, contacts and calendar, is that there are a bunch of different providers that give you information that contribute to the kind of amalgamated view that you see when you go to the People Hub or when you go to the calendar. Both of those apps are showing you this combined view of your contacts from all of the different social networks you are a part that you've configured on your phone. And so those contacts are all there, all mixed up together. And in actual fact, I'm sure, as you'll know if you've got a Windows phone, when you go to a particular contact, what you're seeing in one contact is you've quite often got a contact is a linked entity where you've linked the Facebook version of that contact with your Microsoft account, maybe with an Exchange contact. So it all ends up as being, because it's the same person, you link all that information together. So all of those different account providers can contribute to the data that you can access. So some of the data is fully accessible programmatically. Others, for contractual reasons, you kind of you'll only get maybe the picture and their contact details. So first of all, let's look at contacts in this kind of out of those two. And before we kind of dig into programmatically how you access those contacts, there's one particular concept that applies both to contacts and to calendar APIs that you need to understand. And that is this idea of brokered versus direct access APIs. So essentially what this means is that the brokered APIs means that the phone gets involved in it. It's the same as if you saw the last session yesterday, we were talking about file open pickers and file save pickers and the share picking and the share contract. All of those, the shell kind of gets involved in the middle and sticks up some UI. What that means is that as soon as the control goes from your app over to the shell APIs, then the user is fully in control. So it's up to them whether they select the contact or they send that email or they pick that file. They're involved. It basically means that you don't need any special capabilities in the manifest when you use these brokered APIs. Contact Picker is the brokered API for contacts. Now, if you don't want to use the contact picker, you don't have to, because you can still get programmatic access to the full list of contacts. But this is what you call the direct access APIs, where you're not borrowing the built-in apps API. You are going to you might use the built-in apps API, but you might also choose to put your own API up. So your own UI up. Sorry, get this right. So if you're providing your own UI. And getting programmatic access to contacts data, then you need to declare the contacts capability in the manifest. And the same applies with appointments, where you need to put the appointments capability into the manifest. So this is a table that gives you a list of the different contact APIs. Brokered ones at the top basically means for Windows Phone, Contact Picker. On Windows, we've also got Contact Manager.show contact card and show delay loaded contact card. We don't support contact cards on Windows Phone. Underneath that, the direct access ones, where you can request a store with request store async, and that gives you programmatic access to then find contacts async through that store object. And then that will return, you're doing a search that will return one or more contact objects that you can then get the information out of. For Silverlight 8.1 apps, Contact Picker, the brokered UI, is not available, but the direct access Windows Runtime APIs are all available. Actually, Silverlight Apps has a bunch of launchers and choosers still accessible to it, which have been available since Windows Phone 7.x days. They're listed at the bottom, so you can actually get at contacts details that way. So there's kind of both the Windows Runtime apps and Windows Silverlight apps have kind of equivalent capabilities, but perhaps not quite the same way. So first of all, using the Contact Picker. The Contact Picker, new it up. Then there's a couple of fields that you might set if you're using this API on Windows, and there's a convergence point here. If you try and set those properties in shared code, if you've got a universal app, if you try and set them in the Windows Phone head, you'll actually get a not supported exception. So you'll need to hashif-def those out if you're sharing code in a universal app. So you can't set the commit button text or the selection mode. Those are not supported, and in fact you can't even set them. Then on Windows Phone, again, with Windows, there's this desired fields with contact field type. So you can say to the Contact Picker, I want to get back the email, or I want to get back the phone number, or I want to get back the address from this search. And you've got to set one of them, and only one of them on phone. On Windows, on big Windows, you can select one or more of them. So once you've configured the Contact Picker instance, then you just call pick contact async. And at that point, control switches over to the kind of built-in dialog on the phone. So you're seeing the Contact Picker choose a contact dialog, which you can see on the right there. That's actually a shell bit of UI. You don't program that. This is what's invoked by calling pick contact async. You can also pick contacts async allows you to select multiple contacts, and you just get the same UI, but this time with checkboxes. You even get checkboxes that expand out, and you can choose, if you've got this example where we've asked for the address, you can choose between the home address and the work address. So very flexible UI it gives you for free. For the direct access APIs, we've got this contact manager.requestStoreAsync call. That method gives you back a contact store object, and that's the gateway to doing searches, programmatic searches against contacts. You do need the contacts capability for this. So then you can call find contacts async. This one is parameterless, so you're just getting all the contacts. You can supply a search string, so it will match on email address or name or some such, or the phone number. And then, well, we're just putting up popping up a message dialog that to show you how many we've got. So that's how you get programmatic access, and then you can work with the contact data. Now, what you get back from our search is a collection, a read-only list of contact. So it's read-only list. You can't actually change the contact through this. And it has a bunch of properties, loads of them. So you can go and have a look at the documentation. There's a little sample of what you get over there: addresses, connected service accounts, the display name, obviously the emails, and all the various different fields. So you can get lots of information back about the contact. Right, I've got a simple little demo to show you how this works. I've got the Contact Picker. I'm going to run this on the emulator. And it is it's a simply stunning UI. There we go.
Oh,
how good is that?
That took a while.
That did. Yeah, I spent a long time dreaming up that UI. I tell you. What happens when I hit the button? Not a lot. So what happens is button click. So here we go. It's actually what you saw on the slide. We new up a Contact Picker. We add just one of these. The others are commented out, but just to show you how you do it. Then we call pick contact async. And then this is unawaitable. There's no and continue on this, perhaps strangely, compared to some of the other APIs that have done that sort of pattern. So we're then going to see if we've got a contact back. If we have got a contact, we're going to stick up a dialog to show the picked contact details. We're back in the app at that point, and we're actually going to save that contact for future use. So let's actually go and do that. Not that one, this guy. Pick the contact. I've actually entered 3 contacts onto this. So there's me, Jumpstart 001 with a stunning thing, and then Matthias there. I'm going to pick Jumpstart 001. Now we're back in our app. We've got the contact, and we've got that phone number that was associated with that contact. Not very complicated. Nice and simple, in fact.
Very cool.
Yeah. I've also got this contact searcher, so let's stop that. And this is using the direct API, so let's just run that up. Set that as the startup project and run that one instead. And this one, it's probably got an equally stunning UI.
That's running on the device, I think.
You do?
I think that's running on the device.
Oh. Oh, right. Yes. Thank you. Okay, thank you so much. Yes, okay, let's go back to the emulator and try again. That's why I was staring at you thinking, is nothing happening? Okay, here we go. Ah, yeah, how about that? The UI gets better. The UI gets better. Actually, it has got a list on here. So, so what we've actually got is a button and a list view. So we're going to list our contacts when we've got them back. Now, the first time I hit this button, it's going to fail because unauthorized access exception.
Of course.
Because I haven't asked for that capability. So let's go in and ask for that capability because this is using the direct access APIs. These capabilities, we need to have contacts. So we can run that up again. And this time, we found 3 contacts and we're listing them on the screen. How about that? Breathtaking UI. And the code for that is pretty simple as well. Here's the search contacts. We called request store async. We awaited find the contacts. We got our response back. We popped up our dialog to say, yeah, we found 3 contacts. And then all we did is the list view on the screen said it's item source to that collection of contacts. Obviously, that's a pretty dumb example, but you might think of something more interesting that you could do with that. Right, some differences from Windows Store apps. Contact cards are not supported on the Windows Phone. So there's this thing called contact cards, which are kind of little transient UI that pops up in a Windows Store app running on big Windows. And there's a couple of APIs around that, which are show contact card and show delay loaded contact card. We don't have those on Windows Phone. And also there's this thing called contact action. So if you do have these contact cards, it comes up with a kind of an abbreviated little view of a contact. And there are links on there like send an email or get a map to the contact's address. And you can actually link to those. So those are built into the little UI. And you can actually activate particular apps to handle those when the user taps on those links. We don't have that. And there's some contact-related app extensions that are also tied in with that. So a few things, we've only got a subset of the capabilities we've got on big Windows. That kind of reflects the fact that we're not going to want to have transit UI on a phone screen in quite the same way. You can code up your own solution that does something similar. But you can also have app custom contact stores. An application can create a custom contact store. So an application can have its own collection of contacts. Which you can add this time it can add contacts in directly without user confirmation. Any contacts you add in that way will also show up on the People Hub on the phone mixed in with all the regular contacts. So they just become, first party contacts as far as users of your phone are concerned. But they actually they are belonged by your app. So what actually interesting, you can actually add. So they can be linked because they're kind of in the same way as I said. You can have a linked contact that is a linked one entity that is a Microsoft account entity, a Facebook entity, and you know that these are all the same people, so you link them together. In the same way, you could have a My Awesome Contacts app entity, and that could be linked to other contacts on the phone. You can also add custom properties into these custom contacts of yours that are hidden. So you can store some additional data associated with that contact, which you can use programmatically. To create a custom contact, you create or open a sync contact store. So this is creating this would create or open an existing app custom store for your app. Then you create a new stored contact object, set some properties on it. This is just a subset of the few that you can set. And then that iDictionary string object props there, that's how you put in these kind of hidden properties that you can have associated with a custom contact that you can use a bit like tags, if you like, that would enable your particular app scenario to work. And then you call contact.saveAsync. and an application can search through it. Now, the interesting thing is that a user obviously the app can see its own contacts and can get them and can enumerate them and can change them. If the user tries to edit one of these custom contacts through the regular People Hub, what will actually happen is you'll get a dialogue such as that shown on the screen there. The user gets a dialogue like that saying, actually, you can't change. Well, this particular custom app is called Make a Contact. You can't change the details for that contact on your phone, but you can add additional details. So what it actually does is it creates an additional phone contact with the same name and then links it to your Make a contact. So you end up with a linked contact on the phone, which to the end user's point of view is editable. They can add stuff to it and phone numbers and pictures and all that sort of thing. Doesn't change anything for the custom contact part of that linked entity that still belongs to your app. Right, so now having talked through contacts, now the interesting bit that everybody's been waiting for. No, not this one. Well, you can send an SMS. You can send an SMS. And the way you do that is this windows.applicationmodel.chat message. And you can set a body in there. You can set a title. You can add recipients to it, put numbers on there. And then you just call chat message manager.showCompose SMS message async. And that will link into the normal messaging app. But then the user is in control again. These are another kind of brokered UI, if you like. There are some other, people will search in using an object, will look through the API sets, and there are other APIs in this namespace which would kind of allow you to create a custom SMS messaging app that can handle incoming and become the SMS messaging app. Those are restricted, so they're not unfortunately for the general third-party app developer. So you need to contact Microsoft if you want to build one of those special apps and get specially provisioned to do that. Sending an email, still no attachments. Don't worry, it's coming, it's coming. And so you can just send a boring email with a body in it, and you new up your email message object. You can add email recipients to it, such as that shown there. And then you call email manager.showCompose new email sync. And again, it will just launch into the built-in email app. That will fail if you haven't got any email accounts configured on your phone, as I discovered last week when I was testing on a phone that I was convinced had email. It had loads of contacts and everything, but I just unchecked sync email in the settings, and so you'll get an exception, so be warned. All right. Hey, sending email with attachments. There are two ways of doing this, actually. The first is perhaps kind of an accidental way, so this is not quite the cleanest way. Yesterday we talked about the being a sharing source, and we talked about you can share files. So if and sharing source doesn't know who the share target is. That's up to the user. They select who to share with. So your app just shares some stuff out, and it could share simple text. But what it can also do is share files. So if you share files, and then the user in the picker, like that's the top picture on the right there, where you've got the share. This is the share picker UI that the shell puts up when your app is asked to share something. If they choose Outlook, then it will launch into Outlook, and you will be into a new email message, and your file will be sitting there as an attachment to that new email message. The user's uncontrolled and is in the email app then, and they do their business, send their email, do send, and then it will switch back to your source app again. But the more direct way of doing it is to use email manager.showCompose new email async and pass in one or more file attachments. And an interesting side note about this: if you send it, they allow the user to choose a large high def photo from their camera roll. They will be automatically downsized by the email app as they're sent out. So this is the code to send it directly. An example there, we've got a storage file where we're getting a file that's in the app local storage at the moment, local folder.getFileAsync. And when you do this with an email attachment, it needs one of these random access stream reference objects. Fortunately, they're actually very easy to create from a file. You just call random access stream reference.create from file and pass it that storage file object. So that will give a random access stream into it, and then you can new up an email attachment object, give it the name, and then pass it that random access stream object. And then you new up your email message, attach your recipients, and this time you'll attach an email attachment object as well. And obviously you can have more than one email attachment. And then you call show compose new email async, which is this is exactly the same as the boring one I showed you before, but with the difference that we've got the email async on there. Okay. So next we'll actually just give a demo of that, and you have to watch me here, Matthias, make sure I don't do the wrong thing. I borrowed Matthias's phone for this because I tried to configure, you can actually configure an email account on an emulator. Get the right button.
Power button on the top.
Yay. So there we go. This is a phone.
This is a non-Nokia phone, the HTC.
Yeah, okay, and keeps going off. Go on. Okay, thank you. Right, so there, we're in the phone, and I'm going to open open a next sample, which is it's actually the same one. It's not the different one at all. It's this one again, Contact Picker. Yeah, so that's a startup project. But this time I want to go to the device because this has got an email account configured on it. You can, like I said, you can actually configure the emulator normally, but I think it's possibly because I've got a UK PC and I'm in the wrong time zone, and who knows why, but I just couldn't get it to work before. But normally you can just add an email address and it will sync all your contacts and life is good. But that didn't work, so I'm going to run this on the device, and you'll notice there are some other buttons on this. This pick contact, that's kind of pick contact button at the top, so we can pick our contact, and we're going to go and find the Jumpstart contact, which we've carefully added to provide non-controversial data, and it's got the mobile number 555-555-5555. So we've picked a contact, and we can send an SMS. And I think here we are. We've gone into the to send to Jumpstart. So we're sending a text SMS to this user. We can send it to 555, and who knows what will happen? No. Oh, there's no SIM card in it. Oh, that's too bad. But actually, that's fine. I'm quite cool with that.
Right.
What that code was? That is just that simple. So the that recipient, that picked contact, the SMS one, I picked the phone number that we got from that picked contact and put that in as a recipient. There was the body, and we just called show compose SMS message async to launch into that. So that was kind of interesting, and we can get better now. We go back from there, and we can send an email, and now it actually puts up it chooses a picker to send. There we're into to send it to myself, sending a test email sent from my Windows phone. We could send that, but again, I'm not going to bother because I don't want to. Don't want to get an email like that. And we can send an email with attachment, which allows us to pick a photo, or actually I can take new pictures. Take a picture of there's Matthias. Thank you so much. That's awesome. Accept. And yeah, we're sending that by Google Mail, and this time there it is. Our picture is embedded into the email. Yeah, that's really nice. So is this on Wi-Fi? No, I don't really want that picture. Get rid of that. Kill. Go away. Thank you. And we're back in our app. So nice and easy. Right, lastly and not leastly, working with appointments. Whoa, what a complicated slide. Actually, this is kind of similar to the one I showed for contacts. We've got brokered APIs where you don't need the appointments capability, and it calls into the built-in calendar app. And there's a whole bunch of APIs you can call, called show add appointment async, show appointment details async, show edit new appointment async, show remove appointment async, show replace appointment async, show time frame async. So you can go and show and edit and add. You can link into the kind of normal appointments dialogues that a user is used to using, and all those are available. There are, of course, this direct access where you can request an appointment store and then act and work on it to work with appointment calendars and appointments. It looks complicated, and it is, but what you need to think about is 3 kinds of apps. First of all, there's apps that create standard appointments in the regular calendar. So they just want to launch the built-in calendar app UI and allow the user from your app to add in, remove or replace appointments. So it's kind of programmatically interacting with the built-in calendar app. So nice and simple. Then there's the second category is calendar view apps. So the first one you just need the brokered UI. The second one, calendar view apps, this is where, well, you might show some of the standard calendar app UI, but you want to actually provide some of your own calendar UI as well. So you want to programmatically get back appointment details, and then you might put them up in your own UI for whatever reason. And these will use the direct access APIs to programmatically get appointment details back. And then you can still use, there are instance versions of the show add, show edit, all those kind of those show APIs that were in the brokered UI. You can still call of them as well down here in order to pull up the kind of the standard UI in order to work with those appointments. But the third one is, this is where you're a completely new custom appointment calendar. You want to be the appointment calendar. You want to replace the built-in one. So this is where you are a big shot in this game, like Facebook or somebody. And this would have its own appointments calendar and also throw up its own particular UI. But it's still working with appointments type entities, and you might also want to be putting those appointments into the phone so you get alarms and reminders and visibility in the regular appointments app hub all the time as well. So those are the 3 categories. So first of all, using the brokered UIs for creating an appointment, well, you need to get a date and time, and you need to work with date-time offset objects. So this is important, to use the time zone offset to find out what your local time zone offset is, and then create a new date-time offset object and include that time zone offset in it. So this is all about getting dates to be correct wherever you are, which of course is always something that's tricky to do. Set a start time, subject, and this sort of thing, and then call appointment manager.show add appointment async. There's loads of other appointment APIs, of course, show remove, show edit new, show replace as well. You can easily find an appointment in the calendar app and show details of it, and actually you can simply show the calendar app for a particular time zone very easily as well. Let's just give you a quick look at what that looks like. Very simple, a little demo. I think we're done with you. Thank you. So, first of all, where's my emulator gone? I didn't run it. Let's run it. Okay, this is my emulator. And first of all, I'm going to, we can actually find the, we're in, oh, hang on, I'm running the wrong one, that's why. Confused. Appointments brokered UIs, let's run that one instead. These are the brokered UIs, you don't need an appointments capability. And this one is going to pop up, and yeah, we can show the calendar. That's exciting. This is just going to the regular built-in calendar app, yeah, there's nothing much happening on this emulator, is there? No, nothing happening.
The emulator has a lonely social life.
Yeah. Oh, that's really tragic. There we go. Okay, so nothing at all happening. But this is just a regular calendar app, and you invoked it from our app. Obviously, you won't be surprised to see the code is trivial to do that. Where are you? Okay, there we go. Yeah, so we've set a time zone offset from us. The start date is datetime.now, but we've applied the date time zone offset, and we said, oh, I'm interested in, well, that's just a hint actually. It's completely ignored on the phone. On big Windows, you can say, oh, I want to see a month or a day or a year or something, but this one just launches into the regular phone thing. Now, the other one, the other button on the screen, this one, create appointment, actually launches into a much more complicated thing. So we can say jumpstart. This is just some UI that my app has thrown up. which allows me to enter some details. But you could supply all of this programmatically. So yeah, well, let's say it's all day. Why not? Yeah, there's kind of loads of stuff, organizer and everything. I'm not going to bother putting any of that. And we just say create appointment. Now this is the built-in calendar API. So which kind of looks the same, because actually that's kind of a weird demo. So really what you would do in a real app is you'd get some information from the user, whatever your app scenario is, in whatever way. You would populate an appointments object with as much data as you've got, and then you would call show add appointments, which is exactly what this has done. I'll show you the code over here. So this is an adapted version of a UI SDK sample, which is why it's so verbose. But here we go, we're setting the subject. I could have filled in loads of dates, loads of fields on that UI. But basically what this is saying is I'm just populating an appointment object. And finally, when we've populated it all, there's no, we haven't got there yet, appointees, participants. This is how rich an appointment object is. Finally, we call, add appointment to calendar async, go to definition. Which is this method here, which all it does is calls appointment manager.show add appointment async. And we get back an appointment ID. So we save it and say, yeah, we're good with that. And there's appointment ID shown at the bottom there. So we've actually allowed our app to programmatically create an appointment. The other one, the one that I accidentally wrote up before, is it got up before, is the programmatic access, where you can find all appointments. I'm going to search for appointments. I'm going to hit this search button. And first of all, it gives you back a list of calendars. Actually, there's a phone calendar, and if you, on a normal device, you'd actually see a list of them. So if you have a Hotmail account configured, for example, or an Outlook.com account configured, you actually see public holidays calendar and your personal calendar. There's loads of different calendars. This one has only got one, and if I click on it, there's one appointment in it, which is the Jumpstart appointment, which I just created. And the code for doing all of that is this get appointments in here. So what we did to achieve that is, first of all, on the button I requested the appointment store here, and then using that appointment store I find all the calendars, and I put the calendars into a calendars list view, which is this blue one here. And then when I hit calendars list view selection changed, I got that appointment calendar. I then did find appointments async for all appointments in that particular calendar. And then I put that to the screen. And lastly, this bottom one, when I click that, what's going to happen is this is going to happen. I'm going to get again, another reference to the store, and then I'm going to call appointment store show appointment details async, and that is going to call into the regular app again, and this is now we're into sort of the brokered UIs again. This is the user's normal experience for working with appointments, and we can edit it, or we can delete it, and all the rest of it. Oh, I just did all that. There you go. That's a normal example with some more different calendars on it, which I did on a real device, which is kind of a little bit more interesting. Finding appointments, this is actually the code I just showed you there. And adding appointments, this is where you're calling out to the brokered UI to go and do that. And actually, I just showed you that demo, so we're done. So that's it for calendars and appointments. There's actually much more to it than that. There's this idea of calendar and appointments. They actually roam between devices. So there's a concept that's important to understand, which is the local IDs and remote IDs. But I'm afraid just isn't time in this format to go into that kind of detail. So if you could please consult the documentation. We are going to take a short break, and then for 10 minutes. And then Matthias is going to be back to take us through cameras and video, which is a great session as well. See you soon.
And welcome back. The next session, this one, is a session on camera, media, and audio. This is a really exciting session with a lot of really fun demos, and we're gonna jump right into this here. Okay. We're going to cover a lot of stuff. We're going to cover opening, editing, saving our photos, and we're going to edit them with the Nokia Imaging SDK, which is a really great toolkit for applying filters and doing some editing with your photos. So we'll show you how to pull that up and make that work. We're going to go over capturing images, capturing video using your phone, and very exciting, we have a screen recording API. So you can just turn on screen recording with a really simple couple lines of code and just record your screen right on your application. We're going to cover video editing, which is also, I think, pretty exciting, the idea of editing video right there on your phone. And then lastly, we'll go over background audio. So, photo editing on Windows Phone. The first step to photo editing is we need to get a photo. And if you're familiar with the Camera Capture UI from Windows 8, you may be asking, where's the Camera Capture UI from Windows 8? And it's not available on the phone. Neither is the Windows Phone 8 Photo Chooser task or Camera Capture task, although they do still work on the Silverlight version of Silverlight 8.1, not on Windows Runtime. Instead, we're using the File Open Picker. That's the new Photo Chooser task and Video Chooser task. This is actually a really cool implementation because it means that we can pull single or multiple media files, not just photos or not just videos. And we can take photos and videos. It'll also launch that very familiar Photo Chooser task UI so that we can take new photos or videos with the camera's built-in UI, or the phone's built-in UI. And it covers most of the scenarios that we have with the Camera Capture UI from Windows 8. And it's available inside of Silverlight as well as Windows Runtime APIs. For a little bit more information on the File Open Picker, you can see our session 13 on sharing. But this one is going to cover it just as it applies to camera
Session 10.
picture. Session 10? Oh, man.
Yep.
This is
I moved it around. Sorry, it's my fault.
This is just as it applies to photos and videos.
Yep.
So in order to get the access we need to make sure we have full media library I/O access, and that means going into our AppX manifest and turning on our pictures library, turning on our videos library, and if we're going to pull pictures or videos from the SD card, we're going to want to turn on removable storage as well. The read-write access, the photos and videos, we can pull photos and videos without using any sort of intermediary shell UI, and we can do that just by using the known folders. And we covered known folders in our storage session, but we can use those known folders, pull those images, pull those videos straight into our application without doing any sort of intermediary UI. This is also available for Windows Runtime and Silverlight applications.
Yeah, so the capability you only need that for that direct programmatic access.
Right.
And so you don't need it if you're using the File Open Picker.
Right, and so that would be like pressing a button and just getting a photo or getting a list of photos from your UI instead of jumping outside the application to come back in.
Yeah.
For editing photos, in the demo you're going to see we're going to use the Nokia Imaging SDK. It's a really easy to use imaging SDK that Nokia provides for free. It's got a huge amount of really cool features and samples, lots of filters, lots of effects. You can do crop and resize and rotate. It's incredibly fast and incredibly efficient. And one of the really cool things about the Nokia Imaging SDK is you can pull in like those really high-res images you get off the Nokia 1020, the 42, 41 megapixel images. And it actually has a proprietary technology where it just goes through and it'll, when it applies a filter, it'll grab a chunk of the image, apply the filter, another chunk of the image, apply the filter. So it's got a really low memory profile. It's just a great SDK. If you're looking at doing any sort of image editing or filtering on Windows Phone, you should definitely check it out. And it's also great because it's a little cross-platform. It's available for Silverlight and Windows Runtime and Windows applications. We're also going to be using in the demo just a little bit of writable bitmap extensions, which is a great little library that takes the writable bitmap that we have available inside of Windows Phone and just brings it a little bit further, applies some of the availability that we had in older versions of Silverlight and WPF. So it's a great library, and those are the two libraries that we're going to be using to kind of show off some of our editing capabilities. So editing a photo with the Nokia Imaging SDK is pretty simple. We take the image stream that we got from the image that we've pulled into our application, and we just create a new effect. Using a new effect, a filter effect, we hand it that image stream, and then we can define any of the filters that they have available. We hand that filter into our writable bitmap renderer, along with our a bitmap that we want it to come out for, and then that bitmap, and then we just run that renderer. We can take that bitmap and just apply it straight to an image.source. That image would be a XAML control, and so we're taking the image source of that XAML control and applying the bitmap to it. So take a look at the demo and show a little bit of photo editing in real life here. Okay. We're going to run this, and we're going to look at the file open pick. We're going to pick an image, and we're going to apply a filter, and then we can save that image. So we'll start by show the Okay, so here's my fantastic UI, and I can take a picture. I'm going to actually use the camera to take a picture. And here we have Andy. This is usually what he's doing when I'm doing my sessions.
Caught me asleep.
Right, and so I'll accept that photo and pulls it into the application, and we can apply a filter to it. We can apply the filter again and again.
What's this filter called?
And then it's the antique filter.
Oh, how very appropriate.
And then we can save it and then pick the place where we want to save it. Maybe we'll save it in our pictures dictionary, or our pictures folder. And just save it there, and now we've saved the photo. So let's take a look at the code that made this possible. There we are. Okay, get out of here. There we go, okay. The file open picker, scroll up to the top. Okay, so the file open picker was where we started, and it was actually exactly the same file open picker that we've been using, exactly the same way we have been using it before. So what's the difference? What made us go to the images and the pictures and the media files instead of just opening a file? Well, we handed it the supported image file types. We handed it a list of image extensions, and because it has those image extensions, it looks at that and it says, oh, they want images, and so we're going to take them to a place to get some images.
Which is the camera roll.
Right.
Yeah.
Exactly. And so then we got our image. We pulled it into our application, and then we wanted to apply that filter effect to it. And this is exactly the code we saw in the presentation, where you just grab that image source, create a new filter effect, apply that filter effect, and then push the resulting bitmap back to our image source. For saving, it was just the same file save picker, and we were able to hand it a location that we wanted it to go to, and that opened up our pictures library we were able to save. So fairly simple. I like the fact that we get to use the file open picker and the file save picker to APIs that we're already familiar with, and we just apply it to this sort of special case where we're looking at photos or videos. So jumping from photo grabbing and photo editing, we're going to look at capturing and screen recording. And when we say capturing, what we're talking about is not jumping outside of our application, not going to the phone's UI.
So this is kind of where you're being a camera.
Right. You're acting as the camera yourself. and everything is happening inside of your application. So the windows.media.capture. Windows Phone 8 provided the windows.phone.media.capture. There's a lot of namespace discussion that we'll get to at the very end of this session, so kind of bear with it here. Windows.phone.media.capture using our photo capture device, our audio video capture device, and then we'd apply that to a XAML element for a real-time preview. With Windows Phone 8.1, we use media capture from a slightly different namespace, windows.media.capture. And it's going to support our low lag videos of burst mode if we want to take a bunch of videos all at one time. And this is going to be the most common API. This is a mostly common API for Windows and Windows Phone. There are a couple phone-only additions because phones are acting more and more like cameras, and phones are certainly more like cameras than tablets tend to be. So the basic capturing concept is that we show our camera stream in our XAML UI, and we use the capture element for Windows runtime apps. Whereas before we would be using a video brush. And in fact, the video brush still exists in the Silverlight 8.1 application. So if you've been using video brush, you need to update from your Silverlight 8.0 application, you can update to Silverlight 8.1 and keep that video brush with its media capture preview sync, and all of that code is pretty much still going to work. But the capture element gives us this real-time parameter control, so we can do real-time camera parameter changes like focus and zoom and exposure and that sort of thing. This does mean that we have to go into our AppX manifest and we need to turn on the capabilities for microphone and for webcam because we're using the microphone and the webcam. So a capturing solution for so if we initialize media capture, we can see this is good news. With Windows and Windows Phone, our media capture initialization is fairly simple. We create this new media capture object, we initialize it as an async, and then we take a XAML element, the preview element.source, and we say that source is our media capture object, and then, okay, media capture, start your preview. Compare this to all the code we had in Silverlight and then we still have in Silverlight 8.1, where we have media capture, we initialize it, and we get a preview sync, we have a video brush, we have video device control. It's a lot more code. It is a less straightforward API for getting that image, that live camera feed into the XAML UI, into the application. And then once we have that applied to the XAML, once we have that preview inside of our application, we can capture a photo fairly straightforwardly. We construct some image encoding properties, 640 by 480, seems like a nice picture size. And then we can apply, we get a new folder by grabbing a known library, a known folder, a library, basically any sort of storage folder that we want to use. We can take and create a file inside of there, and then use that media capture object to create the photo, capture that photo to a storage file. Now in this instance we're using known folders, but as I said, you can use any storage folder. You could save it just strictly to your local storage for your application, or you can store it to any of the known folders, the pictures folder, or the camera roll folder. We support hardware button the hardware camera buttons, both the camera half pressed, which is usually used to initiate focus, and then the full press, which is usually used to capture the video, or capture the photo. Recording and playing a video is actually pretty similar to taking a picture. We have a media encoding profile instead of an image encoding one. But it's the same thing. We grab some storage file, in this case our videos library, our known folders videos library, and we just take our media capture object and we start recording. We have to, with video, obviously, we have to stop recording. So we've got a method for that, stop record async. And when that recording is done, we can just take that stream that we get from the video file that we had created and set it as the source in our playback element. Changing the camera parameters, which can be done real time, is as simple as in this case we've got a slider XAML control, and we've just connected those that slider XAML control to the properties inside of our zoom control. And so in this case, we'd be using the slider to zoom in and out dynamically. We'd be able to see all of these changes inside of the preview in our XAML. Which brings us to our next demo. Which is basic capturing. We'll stop our last demo. Okay. Make sure I've got my okay. And what we've got here is we've got the option to do a photo page or video page. So we're going to take a quick look backstage. Oh, but first we're going to look at what the initialization looks like here. So we're initializing, like we said, we're creating our media capture object. We initialize it. We set our primary use to be photo instead of video. Then we set our image encoding properties. And we launch our media capture. We press continue. And this is a backstage look. Our fantastic team here. And when I hit capture photo, it's opening up our pictures library, it's creating a new file, and I'm going to have to hold it up because I hit pause here, or I hit that, we hit continue, it took a picture, it saved a picture over here on the side, and we can actually do the same thing with our video.
Yay!
And you see, we're looking at the exact same thing, where we've got a camera capture that initializes, and then we are going to okay. So that camera capture initialized, it's going to the same file we had before. We're going to start the video recording, give it a video storage file, start the recording, hit continue. And here we have our video recording. When I hit record, it's going to hit that breakpoint again to start the video recording. We'll get rid of that. Hit play. And now we're recording as we look around the studio, and when we come on. There we go. Now we're recording as we look around the studio. I just put breakpoints in everywhere. And we can stop video recording. There we go. Now we're recording. And we can even hear me saying all these great things. When we stop video recording, it's the easiest thing in the world. Nope. We basically just tell our media capture object, stop recording, and because we've already given it a file to record to, it simply saves that file out. Now, one thing I want to make note of is that this is a universal application. But what's really interesting about this universal application is what's inside of it, which is nothing. There are no files inside of our Windows folder. There are no files inside of our Windows Phone project. Every single file in here is in the shared folder from, let's not move things around here, is inside the shared folder from the app.xaml to the camera capture helper that we've been using, the photo capture page, the video capture page. All of this is cross-platform.
That's a universal app.
It is a truly universal application. Yeah. So, and if we run this on Windows 8.1, set that as our startup project and get rid of all these breakpoints. My laptop is actually down here, and I'm remote desktoping into it. And so, hi everybody. But that's exactly the same XAML, exactly all the same all the same code from beginning to end that we're using on our Windows Phone application as our Windows application.
It's all cool stuff, isn't it? Everybody likes messing with cameras.
Right? Yeah, cameras are fun. It
Yeah.
turns everybody into a celebrity. So advanced capturing. This is stuff that's going to be a little bit more phone specific because the phone is better than a point and shoot. So we've shipped the windows.media.capture.core with some phone-only APIs. These are available on Silverlight as well as the Windows Runtime phone apps. And the coolest one of these, or one of the coolest ones of these, is the variable photo sequence capture. And this is a burst shot with variable parameters for each photo. So if you're familiar with HDR lighting scenarios, the idea of HDR is that you have a set of different exposure levels that you can combine to create this sort of bigger than real life photo. And you can do stuff like that by using this burst mode and just resetting all of your exposure levels for each new image. So in addition to regular photo video capturing, we have a really cool new API for screen capturing. And this is great because when we look at the code for this is really simple, really fun, and it's something that we might be able to use in an engaging way with our users, or if we have an application that's drawing something cool or a game that's doing something cool, we can invoke the screen capture in order to show what's happening on our screen. So when we launch the screen recorder, it asks approval for user approval on the first time that they use it. And personal information like notifications and DRM content is interestingly left out. And so you'll just see the area go black if a notification comes in, so you don't have to worry about your personal information being accidentally screen recorded. So the screen capture is this. We create a screen capture object by simply calling the screen capture API, screencapture.getForCurrentView. Then that media capture that we'd been using to do media capture for photos and videos, it's the same object. We take that media capture and we simply initialize it with the source of our screen capture as the video and audio source. Then we can create the video encoding profile, which is usually we're going to want video encoding quality at VGA. We're going to want to create an MP4. And then it's this familiar pattern that we've seen. Give it a folder, give it a file to save to, and then tell the media capture object, okay, start recording to that storage file. It's the exact same, that's the exact same thing we used to do the video recording inside of our application.
That's really cool and really simple. Huh?
Oh, it's a really simple API, and it's a really simple demo, which we've seen today. I need simple demos because otherwise I'm just going to mess it up. So. So here's the screen capture, and I feel really redundant here because all of this was just in the slide that I just showed you, but we're going to see that hit when we run this application and we start recording the screen. Okay, so I've put a big red block around this, so it'll be a little more visible when we start recording, but we'll hit record. And we see our screen capture starts. Continue. Okay, and I'm just going to type my first name, my last name, and my handle. Okay. And then I'm going to stop recording. And it's going to break on me or something. I'm not sure what just happened there. Let's try that again. We're going to try that one more time. Okay. Hit record. And I've got a very funny name this time and a fantastic handle.
We're not seeing the screen up at the moment.
Oh, sorry. Okay.
There you go.
It should be recording. We stop recording. And there is my video object. And it's flickering for the first time that I've ever seen this happen. But we can actually record this fantastic video flicker.
That's cool. This
Yeah.
is, like you said, for bug reporting or something.
Yeah, and now we have this sort of picture-in-picture, and we can record that picture-in-picture.
But of course, the real use case for this is in games, huh? You know, where I think I was saying on the very introductory session, like
Right.
the key, you know, you got the thing like somebody's in a game and they're about to get through a level. You
Right.
can turn on screen recording, and when they've had their big triumph, you can share the video of their amazing gameplay with their friends.
And what's really neat about that is the fact that because you only require user permission the first time, you could just say up front, "Hey, I would like permission to record the screen." They say yes, you take a 1-second video that you then throw away, and you use that so that every time they get to something that's particularly cool, the end of a level, the big boss, you just turn it on. And when
silently turn it on.
Yeah, silently turn it on, and then when they're done, you say, "Hey, that was really awesome. Would you like to rewatch it? Would you like to share it with your friends?"
That wouldn't be a good experience if they're just about to bust through a level.
Right.
Do you have permission to record this?
Right, exactly. So
Yeah.
it's a really simple API. It's really powerful, and it's just a lot of fun to play with. So. I did actually kick myself out of my presentation. Okay. Screen recording, and now video editing. This is just a fun session. It's just fun to run through this stuff. So this is Windows Phone only, but we have windows.media.editing. And this allows us to build these sort of easy video editing applications. Simple scenarios like video trimming, and we can do complex timeline editing applications. It's available in Silverlight, available in Windows Runtime. In addition to just doing the editing, we can pull thumbnails or stills out of our video. We can change the volume. We can add audio to the end result of the video clip that we've edited together. We can pull these multiple video clips, kind of smush them together, and render them all out. And it'll render the resulting video very much like we render the simple capture video, just using to that storage file using that media capture API. So to implement that simple video editor, we're going to see a lot more code here. We use a media composition, the media composition API, and we can grab a bunch of video files at one time. We'll actually use the file. We would actually use the file open picker, and in a multi-select mode to grab those multiple media files. We'll create a clip from each one of those media files. We'll create a thumbnail for each one of those clips. We can set that thumbnail to some UI source so that we can navigate between the different clips that we've created. And then we can just add those video clips to a view model and use that. We could use that view model to apply all of those images to some sort of list control so that we can show all of our clips maybe in a grid view so that they're easy to navigate, easy to select. The actual trimming part of it is, again, really, really simple. We grab one of our video clips. We say trim the time from start, and we give it some amount of time. We can say trim the time from the end, and we give it some amount of time. And it will take the beginning of that clip, trim that amount of time from it, and basically start. If we trim from start, it'll start 1 second in. If we trim from end, it'll end 2 seconds earlier. Pretty simple. We can add some background music or a background track to our resulting video by pulling in some sort of music file that exists inside of our storage system and simply creating the background audio track from that file. And then we apply that background audio track to the media composition using their background audio tracks.add. So it's a pretty self-explanatory API, which is kind of nice. It's fairly simple. All the operations that we're trying to do on it are fairly easy. Trim this, trim that, add the background audio.
Give that API designer a pat on the back.
Right. And then to play it back and to render it out, to play it back, we have these media elements. These are XAML elements for media playback. We just take that media element and set the media stream source to our composition preview media stream source. And then for the output file, once again, grab a library, create a file, give it an encoding profile, and then render that file out. We have a couple of little options. The media trimming preference, you can either say, I want this at high quality, or I want this to go I want the render to happen quickly. So, we'll look at video editing, and this is the demo where I get to play the irritating parent who shows everybody videos of my kids.
Oh.
Yeah, isn't that great? It's hard because you don't want to stream something over the internet that you have no rights to, and so my children have no rights. Okay, so we're launching this pick multiple files and continue, and this is from our file open picker. Right, so we create our new file open picker, same one we've been using all this time, and we're just going to pick multiple files from it. And we're going to grab a couple of video files here. And when they come in, we're going to create a clip of each of them and add that clip to our media composition. So we're immediately creating a media composition that has all of these clips back to back to back. Then we create a thumbnail for each one of these media clips. And then we add that thumbnail and the video file to something that we're going to be able to select inside of our UI.
Yeah, some object here.
And then immediately we're going to start playback. So everything's going to start playing right now. So this is my little girl trying to help Daddy with his work. Up. And when I try to trim it, we're using that real simple trim API. So I'm going to skip past and try to trim this as quickly as possible so that we can jump past some of this. We see exactly the same thing. We trim the time from the end. And then the one thing that we're also doing is we're repositioning that media element so that it shows us the media clip again so that we get a preview of the trim that we just made.
So you trim and then...
Yeah, we trim, start it over. What's the media clip look like? Trim it again, start it over. Okay. So here she is. There's media clip 1 and media clip 2. And media clip 3. All right, and then when we're all done, it'll just cycle back around. It'll start the whole process all over again. And so this is all one media composition. We could just take this right now, render it out to a file, but we're going to add some audio to the background first. You can see this is actually an audio object that's in our installed. We loaded it with the application in our installed location. And we just get it like we would get any other file. And we create a background audio from that file. So this is just an MP3 we packaged with our app. And it's a couple of lines of code, and we've added it as a background audio track. So now we've got this nice little audio track. We've got our trimmed video files, and we can now save this to our library. And now if we tried to look inside of our library, oh, did I miss something there? No? Okay, that should have saved to my media library, and I'll have to find out why. Yeah, it could be that it just took longer than I expected it to, and then when I jumped in the media library, I hadn't saved yet. So I'm going to stop the application. Sorry about that. And let's see if it ended up saving. And it did. This is actually a new file right there that I had. You can hear hopefully hear the audio come off of that. And this is just the file that I just created and saved out to the video folder.
Hey, I see your daughter had one of those little plastic Windows phones.
Yes, from Mix 2011, I think.
Collector's pieces. No, they're not actually.
Yeah.
There's thousands of them. Yeah.
So that's a video editing. That's audio adding and video rendering out using the media composition API.
Cool stuff.
And so the last element, this has been a bit of a whirlwind, but I think I'm actually on track with time.
The first time today.
Which is pretty exciting. Woo. Give me a hand.
There's a stressed team at the back there. I think, oh, one of them can give us the time. Oh my goodness. Right.
We're like, can we have another day in the studio?
No.
So background audio playback. We got a new API in Windows runtime Windows Phone XAML applications for windows.media.background playback. And the media player class replaces the background audio player. And this is available for Windows Phone XAML applications, but not in Silverlight 8.1 applications.
Yeah. But Silverlight 8.1 can still use the... No, they can't.
We'll get there.
I'm trying to remember my own slides from tomorrow. Thinking,
so the media player uses this two-process model: foreground UI and background playback. And the playback continues in the background process when the app navigates away. But it can also be used in the foreground for playback, even without the media element. So this is different than the Windows 8.1 model, which uses a media element audio category. We actually use a background audio player. We have to make sure that we've defined our background tasks appropriately. You go and create a new background task and say, this is an application that's going to use an audio background tasks. So if you don't do that, you'll get that happy unauthorized access exception. So the process for communication via the background media player is to send a message to the background or send a message to the foreground. This allows us to communicate to the background media player with UI whether or not we're inside the application. Because the background media player makes use of the native media player UI when it's playing in the background. So the same UI that you would see when you're playing music from your Xbox Music application. Which is the universal volume control, system media transport controls. It's just access to the device's universal volume control and allows us to define which buttons are going to be enabled on this as it controls the audio from our application. So the code for implementing background audio is fairly straightforward. We have that background media player, and it's been fairly well designed so that we are listening for that current state change. We always want to know when the state has changed from play to pause to stop. We set the URI source, and we can set this source to either a local package. So we're in the demo, we're actually going to pull the exact same file from the application installed folder that we did with the video editing API. And we just load it right into our background media player as a URI. And then the background media player can play it, or we can even trigger it to autoplay. We can pause it, and we can stop it. Updating the UI in the media player is fairly simple. If you see, we're listening for that media player state changed event handler, and when it does change, it's coming in on the background. Remember that. So we're using the dispatcher to jump ourselves over to the UI thread, and then we're going to look at that background media player and say, what is my current state? And if we're playing, we're going to make sure that our UI is enabled for the playing scenario. If we're paused, we're going to make sure our UI is enabled for the pause scenario. If we're paused, we probably want to start playing. If we're playing, we probably want to start pausing it. And then hooking it up into that universal volume control and the media transport controls, is something we do inside of that background instance. We just look for the current system media transport controls, and we add an event handler for when the button is pressed.
So this is where the user kind of presses the volume up, down, and brings down the transient UI, and you see the, you can stop, pause, and
this is all the shell UI.
Shell UI for doing
and we have to run that in a background in the background because our application has been suspended.
Sure.
It's not in the foreground, and so we have to have that background task to listen for those.
Okay.
And then on that message received, we can do the when the element has changed, or when the playback has changed, we can integrate into that media control and display things like title and artist, and just update all the information inside of the media control. Okay, so I now have 2 resource-heavy Visual Studio projects up. We're going to pull up another one. This one for background audio, and hopefully we're getting nice and tired of that one audio file that we have permissions to play over the internet. But we can run the application, and that you can't read that, but it says this page is intentionally left blank.
And unreadable.
And unreadable.
Left
Right.
unreadable. Yeah.
So we hit the play button. You see we've got our background media player. It's going to start playing, and in fact it already has. And so you can hear it. And now if we hit the Windows button, it's still playing. If we hit the volume up here, you see that we're integrating with that transient media control. We can hit the pause button, and if we hit that pause button, the state has changed. So if we go back into our application, we see that our UI is updated back to making the play button visible and the pause button, or the play button enabled and the pause button disabled. So, summary. This is where we get to talk about namespaces. I know this is what everybody's been waiting for, the namespace conversation. Okay.
I've been missing these namespaces slides. We really
This is actually, there's a lot of information on here, but it's actually a little cleaner than you might think. With Windows Phone 8, we had the photo chooser task and the XNA media library for getting photos and storing photos. Now, if you look across, those libraries are still in place for Windows Phone 8.1 Silverlight. You see the media chooser library, XNA media library. Below them, we also have the file open picker in Windows Phone 8.1 Silverlight and the known folders. So we can use those to get photos as well. And we have those moving forward into Windows Phone 8.1 XAML and in Windows 8.1. So that file open picker is file open picker and file save pickers. Those are the ways that we get photos, we get videos, we store photos, we store videos for everything that isn't old Windows Phone 8. Now, in addition to that, we have Camera Capture UI for Windows 8.1, which is just an additional UI control that we can launch inside of our application to do this capture. That's Windows 8.1 only. In terms of capturing, here are the capture capabilities, or the capture namespaces and capabilities. Windows Phone 8, there's one option. There is windows.phone.media.capture. It's available in Windows Phone 8 and nowhere else. For everything else, we're going to want to use the windows.media.capture. That means for Windows Phone 8.1 Silverlight, Windows Phone 8.1 XAML, and Windows 8.1. Windows Phone 8.1 Silverlight and XAML, so all of the Windows Phone 8.1 applications are going to be able to use that variable photo sequence capture that we talked about earlier, as well as the screen capture, but it's not available either on Windows Phone 8.0 or Windows 8.1. And then the media editing, the media editing is Windows Phone only. This is one of those kind of, I think Andy mentioned it, pre-converged sort of APIs.
We've converged ahead of Windows.
We've converged ahead of Windows, where it's come to the Windows Phone, both Silverlight and XAML applications, but it's not yet in the Windows 8.1 version. However, we do have this the windows.media.transcoding, so we can take those video files that we've captured and we can transcode them, save them out as new video files. And lastly, this is the fun, tricky one, the background audio. We have the background playback that I just demoed is available in Windows Phone 8.1 XAML only. That is the only place it exists. For Windows Phone 8, we had Microsoft.phone.background audio, but that did not come in to Windows Phone 8.1 Silverlight. So if you are building a Silverlight application and you want to use background audio, you need to stick with Windows Phone 8 for now. If you want to use the background playback API, you're moving to...
But it's worth reminding everybody that if you build for an app targeted at Windows Phone 8,
Yep.
that will run on Windows Phone 8.1.
Yes,
You just
absolutely.
can't use any of the all the new Windows Runtime APIs in that app.
Right.
Yeah.
Right. Yes. What Andy said.
Yeah.
And so, and then there's an additional the media element audio category, background capable media. That's background audio for Windows 8.1, and so that exists only in Windows 8.1. So that's kind of hopefully that was a reasonable explanation of the various namespaces that we have for all of our media capture and media storage and background audio and video editing. There's a lot in here. But it's really fun to work with, it's very exciting, and it gives us a lot of capabilities and control when it comes to these really fantastic media scenarios across the Windows platform. So, that's our whirlwind tour.
All right.
And we're going to take a
fun
little bit of a break, and we're going to come back with Enterprise.
Yeah, and a guest speaker. But actually, we also need to announce something now because we are a bit behind schedule. So what we have decided we're going to have to do is the last session that was scheduled for today, which was a short session on tools. We're going to move that on and run that now first thing tomorrow morning for us, clearly. I really apologise if that's the one session you've been waiting for and you've kind of been waiting up late in Europe or something and it's like small hours in the morning. But we do apologise for that, but we kind of, loads of content and we're struggling to teach you go through all of the great stuff that's in Windows Phone 8.1. So we are going to push that on, that session. The tools session will now be the first one tomorrow morning. So yeah. Apologise for that if that's the one you're waiting for, but we are going to finish today's content with a long session, good session looking at Windows Phone 8.1 for the enterprise developer, and then a short look at programming with SQLite.
Woo!
Yeah.